Welcome to the Explainer. Let's just jump right in, because today we are looking at two of the absolute heavyweights in the psychedelic renaissance. We're taking a deep dive into the fascinating neuroscience comparing psilocybin, the classic magic mushroom, and LSD, the legendary laboratory molecule. Our goal today is to look under the hood and see exactly how they interact with our brain's receptors to fundamentally alter human consciousness. We're going to break down what actually separates them in the brain, in the clinic, and really just in our general understanding of them. So here is our roadmap for today. We're starting with 2 keys, 1 lock, then the microgram potency gap, followed by the lid on the receptor. After that, we'll hit entropy in the brain, earthy versus electric, and finally wrap things up with the clinical horizon. All right, section 1, 2 keys, 1 lock. Let's get into their origins. To really understand how they affect us, we first have to look at what they actually are at a chemical level. Psilocybin is a naturally occurring tryptamine made by psilocybin mushrooms. It's technically what's called a prodrug. That basically means your body actually strips off a phosphate group to convert it into the active compound psilocin right after you ingest it. LSD, on the other hand, which stands for lysergic acid diethylamide, is a semi-synthetic ergoline. It's this highly rigid molecule that was famously synthesized in a lab by Albert Hofmann way back in 1938. So you have this really fascinating contrast right out of the gate, right? A fungus that humans have literally eaten for millennia versus a very direct, tightly engineered laboratory molecule. But here is the wild part. Despite those vastly different origins, they are essentially different keys that fit into the exact same lock. Both are classic psychedelics, which pharmacologically means their signature effects depend entirely on being a partial agonist at the exact same serotonin receptor, the 5-HT2A receptor. If you were to block that specific receptor with another drug, the psychedelic trip for either compound just vanishes. It's gone. This shared receptor mechanism is the fundamental reason their effects overlap so incredibly much. Although it is worth noting here that LSD's chemical shape gives it a slightly broader reach, meaning it lightly binds to dopamine and adrenergic receptors too, and as we'll see in a bit, that actually plays a pretty interesting role. Moving on to section 2, the microgram potency gap. The sheer scale of the potency difference between these two is just astonishing. LSD is 100 to 200 times more potent by weight than psilocybin. Let that sink in. It is one of the most potent psychoactive drugs known to humanity. This is exactly why LSD is dosed in tiny, practically invisible micrograms that are usually dropped onto blotter paper, while psilocybin mushrooms are physically weighed out in full, visible grams. The physical quantities you need to actually activate the brain are just on completely different playing fields. But potency by weight is absolutely not the same thing as the intensity of the experience. We have data from a really rigorous double-blind crossover study out of the University of Basel that illustrates this perfectly. They tested 28 healthy volunteers with varying doses to find the exact equivalence between the two. And what they proved is that 30 milligrams of psilocybin perfectly matches 150 micrograms of LSD in overall felt intensity. You can see the baseline match here too. 20 milligrams of psilocybin equals about 100 micrograms of LSD. So while you need way less physical mass of LSD, the peak intensity you actually experience at these equivalent doses is strikingly comparable. That brings us to section 3, the lid on the receptor. Now, you might be wondering, if intensity can be matched perfectly in a lab, why on earth does one drug radically alter human consciousness for twice as long as the other? Well, the answer lies in the actual physical structure of the lock itself. Back in 2017, a landmark crystal structure discovery revealed something absolutely incredible. When LSD binds to that serotonin receptor we talked about, an extracellular loop of the receptor literally folds down over the LSD molecule like a structural lid. It actually traps the molecule inside the binding pocket. Because of this tiny, microscopic lid, LSD is incredibly slow to detach from the receptor. Its signal just persists in your brain long after most of the actual drug has completely left your bloodstream. So because that molecular lid traps the LSD key in the lock, an LSD experience runs for a massive 8 to 12 hours. Psilocybin, however, doesn't get trapped in that same way, so it clears out in a much more predictable 4 to 6 hour window. Think about what this means practically speaking. If you are a clinical therapist and you're trying to schedule a patient for a dosing day, psilocybin's shorter 4 to 6 hour window is a massive logistical advantage over a grueling 12-hour LSD marathon. Okay, section 4, entropy and the brain. Let's look at what's happening on a larger scale. While they clearly have very different durations, both drugs powerfully induce what neuroscientists call entropy in the brain. Basically, they loosen the rigid, normal hierarchy of your large-scale brain networks. Most notably, they drop the structural integrity of the default mode network. This is the part of the brain heavily associated with your rigid sense of self and often negative rumination. By turning that down, it creates this highly entropic, globally connected brain state where regions that normally don't ever talk to each other suddenly start communicating. For the patient sitting in the chair, this neurobiological reset is often subjectively described as a profound sense of ego dissolution. Which leads right into section 5, earthy versus electric. So this is the big question, right? If both compounds trigger the exact same network entropy and hit the exact same main receptor, do they actually feel completely different to the user? You've likely heard people insist that mushrooms and LSD offer completely opposite experiences. But what does the controlled neuroscience actually say when we remove all those preconceptions and expectations? If you ask around, you'll hear this kind of folk wisdom literally everywhere. LSD is bright, electric, and cerebral, while psilocybin is warm, earthy, and inward. It's a very satisfying distinction, right? And chemically speaking, this might actually stem from the fact that, as we mentioned earlier, LSD also lightly engages dopamine and adrenergic receptors. That could make it physically feel a bit more activating or stimulating. But here is where the science gets truly fascinating. The crucial point is that when those researchers at the University of Basel strictly controlled the dosing intensity in a double-blind lab setting, this whole earthy versus electric myth essentially shattered. The participants couldn't really tell the difference. The overall quality and character of the two experiences were remarkably identical. The main, objectively measurable difference wasn't the vibe of the trip. It was purely the duration. So it turns out that electric versus earthy contrast is mostly driven by our own expectations, the physical setting, and a whole lot of widespread anecdotal lore. Finally, let's look at section 6, the clinical horizon. Because of their differing durations and, frankly, their different clinical histories, they are actually being targeted at entirely different mental health crises as we sit here in 2026. Over in the clinical world, psilocybin is heavily positioned to treat treatment-resistant and major depression. LSD's modern therapeutic comeback, on the other hand, is specifically anchored right now in treating generalized anxiety disorder. Looking at the current regulatory race really brings things into sharp focus. Both drugs have FDA breakthrough therapy designations, which is just huge for the field. But psilocybin, which is being developed by Compass Pathways as COMP360, is slightly ahead. They've already knocked out 2 positive phase 3 trials for depression, COMP005 and COMP006. LSD, formulated as MM120 by MindMed, is right on its heels for anxiety, with phase 3 top-line data expected to drop in the second half of this year, 2026. Of course, as we integrate these powerful compounds into mainstream healthcare, we have to look closely at safety. The really good news here is both are physiologically gentle, they're non-addictive, and they have very low toxicity. But we absolutely must consider the clinical nuance. Because LSD lasts twice as long, a difficult psychological passage simply drags on longer, and it carries slightly higher reported rates of HPPD, which are lingering visual disturbances. Psilocybin has its own nuance, though. It binds strongly to the 5-HT2B receptor, which carries a theoretical, though currently unproven, heart valve risk if someone were to use it chronically, like in daily microdosing. Also, they are entirely cross-tolerant. If you build a tolerance to one, you automatically build a tolerance to the other, which honestly is the ultimate proof that they are walking through the exact same 5-HT2A door in your brain. Which brings us to the ultimate question. I'm leaving you with this to ponder. As neuroscience learns to master the locks of our own consciousness, which of these incredible keys, the ancient mushroom or the 20th century molecule, will ultimately open the door to widespread feeling? The science is moving incredibly fast right now, and the answer might just be both. Thanks so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time.